Hi everyone, this is Karthik Anandan. I'm here to explain a simple NLP test classification project. For this, I have taken the NLP disaster dataset from Kaggle, and I'm just going to explain in simple methods how to do it and everything. So let's get started. So I just download all the data from here, and I just put in my all the data train test sample in my local machine in the VS Code editor. You can see it here. So from here we could start. I'll just explain the code and structure how to do it. So the basic thing to do this project is very essential thing is pandas and basic package like regular expression, and I am going to use sklearn. So I just imported the package and the CSV file train and test file. In this, if you look at the dataset, there are some interesting key things like keyword, location, text, and target. Target is just one thing we are going to find out. The target is just a binary 1 or 0. So other keyword and location, some NaN values are that. So right now for a text classification, I'm just going to concentrate only on the text column, only on the tweets, not in other things. So I just imported the text and target, and other things I just ignored it, whatever it is. So if I took the text and target, it is a Twitter data set, all the tweets. So in the tweets, I just taken some sample tweets like five. Like sampling is just it will take randomly, and you can just 5 or 10 whatever you need. So I just taken it and I just converted into list. So just visually to understand how a tweet will be there. So if you look at a tweet, there are certain things that are like a HTTP URL is there, hashtag is there, and the most important the user name. Like these things are that. These are all the noise in this data set. We don't want to train a model on the username, on URLs, and other things. So first thing is you want to do whatever NLP text classification. The first thing is to remove the stop words. So what are the stop words? Stop words is something like very commonly used words like is, was, that, the. These are the common words. I just simply printed the first 10 common words, which does not give that much meaning when you're building a model or in a sentence. These are all the common things. So to get the stop words, I used NLTK. In the NLTK corpus, if you import stop words, you can get the package. In the stopwatch, you can give the language whether you want English or other things, or just Germany, French, whatever you need, you can give it. And on that language, it will have thousands of words. I think stopwords. In that, you can import everything. So this is the important thing. And the first thing in any machine learning project is the text cleaning. Cleaning the text is very important. So that's the first thing we are going to do that. For that, here we have taken the sample sentences. First, I'm going to test with that how to do it. So what are the main things to remove from this tweet or the URLs? You can look at here the line number. Sorry, there's no line number. Sorry, the HTTPS URL and the RT art hashtags and remove the punctuations and the digits. So how to do this regular expression things? I'm just using a website called I will just show you a demo for the hashtag for the username. I'm just using a website called it is called online regular text store. It is a really good thing. In that you can select Python, and it's something which really very helpful. Like I just paste that regular expression, so you can just see the meaning how it is matched at it literally case sensitive from A to Z to all case sensitive 0 to Z underscore. These all things it will select after the word at. So you can say that at Halgood, at Termonic, all the things are. And here also you can look at the website. You can select whatever range you get. Some predefined like you want to select any digit. For that, what you have, all the things it is here in this website. So by using this website, only I just built all the things. And RE is a regular expression. Sub is if you look at the sub is something just a replace like that. It's just return the uptime replacing only. You can see the message. So I just replacing with the empty parameter of the text. So I'm just doing that. Then I'm doing a strip dot lower. Strip is will remove unwanted space and remove stopwords. Remove stopwords is above function. Like it will just the text will be split, and if the each word is in this stopwords or not. If it's not in the stopword, I will include it. If it is, I'll just leave it from the stopword. These are the basic text cleaning process. Uh, I just included some test, and you can see the output of it. So so this is the tweet, and this is the output. So it will just only almost surely flight officials say New York Times. This is the important thing we needed. Other things are like 370, ESTTPS, all are removed. Like this is another great companion. Some tweets I just cleaned it up. So Ireland, how other things has been removed in this tweet. So this is one thing, and you can look at here. And just last example Sunday during the football that 9 a.m. to 11 p.m. only it will have the most essential thing. You can see here that the PM is unwanted thing is that still there are a lot of cleaning you can do. I just done a minimum cleaning to know how to do for your example. So this is a one text cleaning, and next one is lemmatization. Lemmatization is you can see here the example. Lemmatization is nothing but it will remove the unwanted. It will shrink the word to be to shrink the word, or it will replace with the common words like that. If you look at here, hippos will be written into hippo, like that. Oranges will be written into orange or similar, or not like that. It will be changing. So lemmatization is the one main thing we want to do. So if you after the cleaning the text, you can see it will be much cleaner. So lemmatization is very simple, and it is very powerful to in the NLP side. So I just apply this function called clean text and lemmatization. Lemmatization text is here, and clean text is the above function where if you saw it. So clean text here. So I'm just calling these two functions by pandas apply method, and I'm just cleaning the df and df test. Df is a train set, and df test is a testing validation set or summation test. So I just after the clean set, you will get the data like this. So just now after that, I just counter the value count. So there are zero means our target, one means not target. So it is totally it is around some thousand data, some 1613. In that 4000 majority are zero and one is string. So it's somewhat equally split out. Once we done the cleaning process, we still it is all a string. So to train a machine learning model, everything should be converted into numbers, and one day we can count it. So to convert into a text into a number, there are certain ways. I'm just using count vectorizer and TF-IDF vectorizer. So what is count vectorizer is just count the words, how many times in each bit, how many times the same word is repeated. So that's called count vectorizer. In count vectorizer, you can give the stopwords also removal again for one more filtration. I just do the stopwords, and count vectorizer just you can fit the trained data set with the df.text, and you can just I just count it, and just by using it I just print the most common word, how many times it occurs. So it is, seems that 9064 times ZX has been occurred in Romeo home. These are the words which is most commonly occurred in this. So count vector. So this one, once you got the count vectorizer, you should use TF-IDF. So TF-IDF is a term frequency inverse document. Term frequency is that how often a given word appears within a document. Inverse document frequency is the downscale that appears lot across the document. So all over the documents, how many times. So after count vectorizer, if you pass the same dataset into TF-IDF, you will get the other form of words like most common you can see which is 56,000. That is 7,000 per row. It is across all the documents. That means all the tweets. So that's the count here. Once we get once we convert it to TF-IDF form, then we can just split the data set by you can just train and split method. By using the train and split method, you can just split the data set, and for the text size I just given 0.2, and I given the random state like 42. So once I divided the data set, this is the shape for train and test. For this machine learning model, I'm just going to use logistic regression, which is a very simple. And the logistic regression is just to give a binary output, either 0 and 1. So the target also is very simple. So I'm also 0 and 1. So it's just a binary form of probability between either which one or that one. So I don't want to dig into most into the mathematical perspective. Just using the logistic regression by a scalar node linear model. There are so many definitions, you can check it out. And I'm just given the solver as a linear, and I just see as a two. This is a very default method. So just we want to import it, and we want to give the explain and the white train part, and you can give the prediction as white prediction. So for this to get the accuracy and FN score, I just use the default scale accuracy model, and I didn't use the configuration matrix. I'll further use that, but for this purpose, I just include the accuracy. If you look at the accuracy with the white test and white prediction, it is nearly 79 point, and F1 score is the both the F1 is the average of both precision and recall. So that also somewhat good 72 percentage, but still it can be improved a lot. But 17.84 is somewhat better for this demo. So once I get that, I'm just building the part with that X test data set. This is a testing data set from the DF test. So once I done it, I just gave the submission, and I just predicted all the values for the testing data set, and I just made it into a CSV file, and I just converted into CSV file, and this is it. So after that, I just I just uploaded my solution in the Kaggle. You can check it out, and I just uploaded the solution file, and the accuracy is not still accuracy is somewhat decent only. It is giving 80 percentage. While accuracy there it is 79, it is really 0.1 percentage is increase, but this is just a sample demo. So for that, that is good. Further next videos I will just upload how to do it in BERT or deep neural network, how to do it, but this is just a demo video. And I just uploaded my solution here. I will just share the link. If you want to just use it, or if you want to know more about it, you can read in that. I hope that's it. Let me know your thoughts. What should I improve or how to improve it? Thank you for watching it. Thank you very much.